Hello, my name is Dominic Levino, and today I'm going to be talking about the analysis of projectile collision. Our outline begins with the motivation, the background, the objective, geometry, boundary conditions, mesh optimization, simulations, discussion, and finally the conclusion. Motivation. Objects upon contact with each other have a tendency to repel back towards their original path or change direction. What is interesting is what happens upon collision between two objects. Depending on the tensile strength of the materials, the force of the impact tends to create an impression. Impressions made in vehicles tend to be made by projectiles that are traveling at a high velocity and have a tensile strength greater than the body of the vehicle. Selection of materials for automotive applications is one of the most challenging problems in real-time manufacturing environment, as it directly determines visible quality and cost of the product. While maintaining power-to-weight ratio, engineers look for material that will provide the most protection to the operator of the vehicle, as well as performance. Coating the exterior of the vehicle in a material that will absorb the force of the projectile impact, while maintaining power-to-weight ratio, would benefit the safety of the vehicle's operator. Background. Testing the density of the material is nothing new. Before the material is shaped into an object of use, it is often put through a series of tests to see how much force the material can handle before deforming or breaking. In the development of combat helmets, research agencies and defense contractors subject prototype helmets to a series of ballistic tests to see if the design provides adequate protection. Rather than creating expensive prototypes, creating helmet simulations allows engineers to perform virtual scenario analysis and subject the helmet models to various threats. Our objective: relieving the stress of correcting vehicle body impressions could save car owners thousands of dollars. The overall objective is the improvement of the material selection for vehicles' fairings with lighter, more durable material, for maintaining its shape and leaving no impressions after being struck by an oncoming projectile. To meet this goal, the following research objectives, ROs, must be completed. RO1, qualification of material for testing. RO2, recreate force impact simulation. RO3, computational design and prediction of impact. RO4, analysis of selected material after impact. The geometry. Two objects are being created to achieve the desired goal. The picture given shows what objects are being created. Notice how the sphere is located 300 millimeters away from the plate. To the right shows the plates that will be used in the simulation. Dimensions of the plate are 100 millimeters by 100 millimeters, creating a perfect square that is 5 millimeters thick. The picture below shows a 9 millimeter diameter metallic pellet. Boundary conditions are applied to change the position of the mesh generated. For this ANSYS simulation, we apply fixed supports to the sides of the plate as shown in the picture. For the projectile known as the pellet, a velocity is applied along the z-axis at 762,000 millimeters per second. The force selected represents a projectile being shot out of a firearm. Mesh optimization. Creating the mesh for two objects was straightforward. Given the dimensions of the plate, the element size chosen was a number that could be divided into equal elements. The element size chosen is 5 millimeters. Number of nodes generated was 503, and the number of elements created for the two objects was 586. To determine if the mesh was optimized, the temperature was set to 22 degrees Celsius, which is ambient room temperature. Equivalent stress and equivalent elastic strain were selected to see if the pellet would make an impression in the plate. Using 5 millimeter size elements will allow for more accurate analysis. Simulations. Three materials are tested to see which would have little to no indentation when impacted by a 9 millimeter pellet. The plate materials selected are ABS plastic, plywood, rubber, pellet materials, lead. Simulations. Here are the results given after the simulation was conducted. Here are the plastic results for total deformation, equivalent stress, and equivalent elastic strain. Plywood results. And rubber results. Discussion. From the pictures viewed in the previous slides, the results show what can happen when a 9mm lead pellet impacts a 5mm thick plate. When the plate material selection was made of ABS plastic and plywood, the results showed that the plate maintained its original shape. Upon closer inspection, the impact site, the results showed no impression made when the lead pellet impacted the plate. When the material selection for the plate was rubber, a different outcome occurred that was not expected. The pellet made a deep indentation in the rubber plate to where it almost punctured the stationary object. The objective was to see which material selection could improve the vehicle's fairing makeup with lighter, more durable material. Given that 2 out of the 3 materials had no impressions made, the results can conclude that the simulation was a success. Conclusion. Not having to worry about impressions made on the bodies of vehicles will save car owners thousands of dollars in repairs. The question being asked is what material can survive the impact of an oncoming projectile? The overall objective is the improvement of the material selection for vehicle fairings with lighter, more durable material that would maintain its shape without an impression after being struck by an oncoming projectile. Out of 3 materials tested, only 2 managed to keep their original shape. We can conclude that the 2 materials, plywood and ABS plastic, kept their original shape and had no indentation. ANSYS simulations carry a wide range of possibilities. Explicit dynamics shows real-life simulations as they occur. With the correct information, ANSYS can simulate how the frame of a vehicle will react upon collision. Instead of manufacturing a life-size model, ANSYS can simulate a scale model of the object and apply real-world conditions. Replicating the simulation in this model can be done, but so is refining the model, using a different time step or a more realistic projectile rather than a pellet. The possibilities are endless. My name is Dominic Levino. I'm a graduate student, and I hope you enjoyed the presentation. Thank you.